Let us see some case-based questions. First chapter, real numbers. A garden consists of 135 rose plants planted in certain number of columns. There are another set of 225 marigold plants which is to be planted in the same number of columns. Read carefully and answer the following questions. So, number of rose plants is 135. Number of marigold plants 225. What is the maximum number of columns in which they can be planted? Maximum number of columns. So this is columns. Consider there is a field in which some plants are planted. Column 1, column 2, column 3, column 4, column 5. In that way it will be extended. Okay. We have totally 135 rose plants and 225 marigold plants. First one, what is the maximum number of columns in which they can be planted? Maximum number of columns. We have two types of plants. So in which we have to find how many columns can be used at the max to plant these plants. So HCF of 135 and 225 we have to find. We have to do prime factorization for each number. So 135 is 5 into 3 into 3 into 3. Okay, next 225. So highest common factor we have to find. Now we will see what are the common factors here. So 5, 1, 5 is common and 2 3s are common. Here these two are not common here. So highest common factor is 5 into 3 into 3. HCF of 135 and 225 is 5 into 3 into 3. That is 9 5s are 45. So total number of columns used to plant these plants are 45. Therefore, the maximum number of columns used to plant these plants is 45. Find the total number of plants. So, rose plants 135, marigold plant 225. We have to add these two numbers. 45 columns. Answer A in first division. Answer A, 45 columns. Here 360 plants. 360 C option. Answer C, 360 plants. Third division. Find the sum of the exponents of the prime factors of the maximum number of columns. We have 45 columns. So we have to factorize 45. Prime factorization we should do. So 45 equal to 5 into 3 squared. So here it is asked the sum of the exponents of the prime factorization. Here the power is 1. For 5 we have power 1. For 3 power 2. So sum of the exponents is 3. 3 option B. What is the total number of rows in which they can be planted? We have 45 columns. In one row 45 columns are there. So 45 plants can be planted in one row. We have 45 columns. So in one row we can plant 45 plants. We have to find the total number of rows. So for rose plants, how many rows we need? For marigold, how many rows we need? We have to see. 135 rose plants. Total number of columns are 45. When we divide, we can get 3. So 3 rows. We can plant rose. 3 rows for rose plant. For marigold, 225 marigold plants are there. We have 45 columns. So when we divide, we will be getting 5. So 5 rows for marigold. Therefore, total number of rows equal to 3 plus 5, 8 rows. 8 rows, option C. Answer C, 8 rows. Last division, find the sum of the exponents of prime factors of total number of plants. So we have to find the total number of plants first. Total number of plants 360, here we found 360 in second division. So we have to do the prime factorization. (360) equal to 3 into 3, 2 into 2 into 2 into 5. So 3 squared into 2 cube into 5 power 1. So sum of the exponents equal to power 2 plus 3 plus 1, 6. So our answer 6 is option D. Thanks for watching.